Hello my dear friends, welcome to Internet Electronics, and today we have this Stenkol battery charge. As you see, it excluding obviously, it can charge 4 AA's or 4 AAA's batteries, and they are not included. So today we're gonna take a look what is this. It was purchased relatively cheap, I think, in Ikea, and hence this is why I bought it, because I want to know how this thing works. Also want to understand, do you need to have all 4 batteries plugged in simultaneously to get this thing working, or you can use 1, 2 or 3, and how you orient them here. So because it's cheaper, or cheaper I would say, a kind of sort of charger, I would like to know how it operates. So stay with me and we're definitely gonna take a look how it goes. So first let's take a look in the box. So we got here probably not much really. Oh, it's gray. I thought it's gonna be white. We have also user manual, so paper aside. Here is our Stenkol. So obviously this thing is not retractable like in other charger that I have from Ikea. And we have user manual. Oh, which it says already good news here. Charge 1 to 4 pieces of AA's or 1 to 4 pieces of AA's. 4 charging slots. Charged are connected batteries or charged individually. I guess they mean plugged in batteries. Okay. They also say even charge is terminated by individual minus or 0 delta voltage detection. Safety by separate safety timer and temperature sensor. Non-rechargeable and damaged batteries detection. Charging status with 2 color LEDs indicator on each slot. Hey, this is actually pretty cool. It's already better than I thought. I thought for like $9, or I honestly don't remember. I need to, I'll put number or how much I paid here. I need to get that receipt because I usually keep all receipts. For few oh, dorks, fancy pantsy. Okay, so what do we have? Actually, there is a little nice manual right here. It's pretty good. So it doesn't say what is the charging current here. Output. 350 milliamp for AA's and 200 milliamp for AA's. That's good. Made in China, Ikea of Sweden AB. All right. So let's plug something in, I guess, and see. Okay, we have this ugly cable here, and we plug something in. So it blinked white. Let's just grab some random A2 batteries. First of all, we're gonna get this and gonna plug this. So this is definitely good battery. It's gonna charge. And right away it's flashing. So it is charging. And now let's pop this one and see what's gonna happen. Ha! It's not stupid. Let's do... we won't be able to do it. Look at this. It's actually pretty smart. So these positive terminals here, they are recessed. So technically you can do that, but it's not gonna do anything, which is actually pretty smart. Okay, this one is... Let's take this Energizer for giggles. By the way, this Energizer is super light. Not sure what's up with it. Yep, doesn't like it. Very good. So as you see, it's nicely charging my Amazon battery. Very good. We're gonna take a look at this later. So what we have here, so as I mentioned, is 4 slot, or as I mentioned earlier, 4 slot charger. Individual batteries can be charged. It can charge AA's or AA's. That's it. Very simple. 350 milliamp or 250 amp for AA's. So probably our next logical step is to pick inside. So for picking inside, we have to make sure this thing is discharged, because it's clearly a switch mode power supply in there. And we probably need a little bit of time to make sure this thing discharge. But after a discharge, I need to find also appropriate torque screw, and this one is, I'm not sure, my guess is like T3 or something. Alright, so we're gonna look for torque screw in the meantime. So I was awfully wrong about T3. This is T10. This is what we need for this guy. Alright. You're wondering why they're using Torx, because Torx is not really that rare. Pretty much every screwdriver set, for example, which the one I reviewed, for example, from Amazon, is capable or has the appropriate Torx. Oh, what? Driver. Probably gonna use this gentleman here to pop this open. Okay, am I missing something? More screws? No. It just probably... Okay, here we are. Now we're talking. Oh, so there's some serious clips around here, so yeah, took me some persuasion. Okay, so what the heck is this? Those are probably thermistor in some silicone thingy, I assume. This is probably unnecessary here. It's a little bit snotty stuff. Okay. More screws? No, it just clipped in again. Wow, it's really cheaply made in comparison to other power and battery chargers. Very cheaply made. But it's good if it's economical and it works, does the job, right? It's another silicone snot here. Yeah, here we are. Okay. Oh, oh my god, take a look at this. It's so boring. It's nothing going on here. Oh my god, this is crazy shit. Yeah, that's a big difference. Okay. This is something we have to analyze. So let me think about this schematic and I come back with some explanations. Alright guys, I have done some figuring out, and let's just quickly about the component base right here, but let's quickly reiterate what we have. So our mains come in here, we have PTC here, we have also, I think, interference capacitor right here in inductor, then we have two capacitors which are 400 volt 4.7 microfarad, two safety capacitors which are in series. have transformer, and then we have a secondary side as you see. So this is the primary side and this is the secondary side. So we have here a rectification bridge, diode bridge. Then we have this driver. So now we can speak about this. So this is DP2353 highly integrated offline current mode pulse-width modulated switch, documentation below. So that's actually screenshot from my website, so you can read more details. So yeah, it seems to be a pretty nifty device. Then we have the spark gap, and in the secondary side we have two rectification diodes and two capacitors. They are 35 volt, and both of them are they? Looks like they are identical, so yeah, they are 35 volts. So this seems to be ground, this seems to be positive. So are they actually have two separate voltages? This is something to check. So then we have all these jars. Obviously the big thing here is this diode, which is Holtec HT46R004. So this is apparently a RISC microcontroller which has a lot of different IOs, works from 2.3 to 5.5 volt, runs at 8 megahertz looks like, and it has internal a resonator. So yeah, this is just all in one diode, and this particular diode runs at 5 volt, hence this 75 or 55 volt regulator. Then we have this apparently quad pack op amp. Potentially this is, I don't know why do you need a quad op amp. I would say this is for the circuit for sensing the current and sensing the current on the devices, so on batteries, sorry. Also potentially it can be used for those two thermistors. Yeah, could be. So yeah, it's really hard to it's hard to trace this. It's white on white. It's not easy, but yeah, this is my assumption, because I don't know why else you would need a op amp here. Just mostly for sensing and application, maybe for comparator reasons, so it can be configured as a comparator. Some of the op amp module blocks here can be like used as an amplification, and some of them as a comparator. So that's a possibility. So those guys are dual n-channel MOSFETs. Here's the link to datasheet. And here's the actually feedback optocoupler here. So this is to run to have a feedback for the main power supply, switching power supply, and this is obviously feedback regulation. And the thermistor, I didn't know what exactly it is. I have to pull this out, but decided not to. Then that's pretty much it. Oh yeah, by the way, over here we have two pairs of resistors. Those are current shunts. So one of them is 10 milliohms, another is 12 milliohms. Right here 0.2 ohm, and this dude is another 0.1 milliohm. This is 0.1, not 10, 100 milliohms. Yeah, so I assume two pairs, they are in parallel, just to set the specific resistance. I think they called even R13A and 13B and 14A, 14B, because looks like this dude is for AAA batteries and this dude is for AA batteries. So why do you need only one? Because this thing does not charge simultaneously those batteries. It charges like 1 second, third, fourth, 1 second, third, fourth, and at the same time it measures the current and voltage on the battery. So this is why there is one, because it's commutating using these transistors, okay, and sampling and commutating using these transistors driven by this microcontroller. I think that's pretty much it. Oh yeah, let's talk about this. I don't know much of there is not much to talk about the microcontroller, but oh yeah, sorry, there is. It's actually 12-bit ADC, which is pretty cool for this cheapo microcontroller, I think. It has not much memory, not much RAM, but 8-bit ADCs. Another thing, I don't know if this is reprogrammable device or it's flash only or something to this extent. Yeah. Here we are. So let's talk about this DP20. Let's move down. DP2353. So this seems to be a pretty interesting device. It has a lot of things. It has frequency shuffling. It has interference suppression mode. It runs at 65 kilohertz and very low well, not very low, low-ish standby power. Shitload of different protections, and take a look at that. This typical schematic. Like poking around right here, it feels like they designed this using this typical schematic. So here's one diode rectification, here's one capacitor on the output side. This is so this is how this driver is integrated. Looks like there is a secondary auxiliary winding here just to power up through VDD this chip. There is also, here's the optocoupler and transistor driven, so this is for the feedback. There is also the standard diode TL431, which is, I don't know what would be here, so probably this D3, I assume, because it's on a secondary side, on the low side. Here's those two diodes here, are they? So yeah, that's pretty much all you can have. It's a snubber network, I assume here. Yeah, that's all. It seems, honestly, my opinion, it's actually very well designed a charger. The only thing is it doesn't have a high currents, charging currents. I think, let me find the specification here and we can talk about charging currents. And the last thing I forgot, have to mention, so here is different capacities of batteries and corresponding charging time and current. So as you see here, 4 batteries, I'll be charging each sequentially. I'm gonna be taking about 8 hours if this is 2450 or 2500 milliampere hours AA battery. So 4 pieces gonna be 8 hours, 3 pieces gonna be roughly 6 hours, and 1 or 2 pieces gonna be around 4 hours. So in current gonna be 0.7 amp, 700 milliamp. Honestly, it's kind of sucks that you have no chance to actually tweak the current, because I'm perfectly fine charging these guys actually with this kind of current. So I would prefer even 1, 2 be charged with this current, you know, because if you push a lot of energy in AA's, it's not always good for them, you know, like in short period of time. Anyways, so 1900 correspond 4 pieces gonna be 4 hours, pretty much the same current, like, but even less battery. Can you imagine pushing almost a 700 milliamps into this kind of batteries? So yeah, I do have proper charger, like it's pretty old, but it's really good. It's lacrosse charger. I always charge batteries with 200 milliamp, even if they are pretty beefy like these guys. So AAA's 900 milliamp will be 5.5 hours for 4 pieces, 4.5 hours for 3 pieces, and 3 hours for 1 or 2 pieces. So, and corresponding current is going to be 0.2 for 4 pieces, 0.275 for 3 pieces, and 0.4 amp for 4 pieces. Look at the same story. Take this 750 milliampere hours capacity battery and put 2 of them. You're gonna push 0.4 amp, 400 milliamp into these guys. I don't know how long it's gonna last if you push that much energy every time. So yeah, this is something to think about, to consider. So these big ones, they're probably the ones gonna be completely fine with 350 milliamps. So if you're gonna charge a battery, like, I mean, I don't care about fast charging, right? What I care about a longevity of this battery, so I would prefer to use 4 of them in order to have this particular current. So yeah, I mean that all 3 or 4 or 2 of them should be similarly discharged. What's gonna happen when one of them already charged, some of them is still charging? Obviously it's gonna be balanced, so I'm not sure. Very interesting scenario. So what's gonna happen if we have, for example, have 3, 1 charged, you're gonna switch to this 0.7 I guess amp mode and charge them faster. So yeah, so this is something to think about. This is also has all sorts of protection over current, over voltage, the charger, the delta V, delta T detection, temperature protection, and things like that, reverse polarity protection. So yeah, it's a decent charger, I would say. The only thing is downside of it that it doesn't have any sort of regulation. So let me assemble it together and try to play with it and see if it still works. So assembling this guy is pretty much just like, I think, just snapping it back on. Yeah, 2 screws. I have suspicion that I lost them because there is no screws in the box. This thing was sitting on my desk for a really long time, but you know what? These clips here are so strong, I don't think it would be even possible right now. Like, yeah, I wouldn't be able to unclip this one. This super, you know, it's not easy at all. It's really tough. So I'm just gonna leave it like it is. If I found those screws, I put them back on, no big deal. So here we are. So our Stenkol is back on. Let's try to play with it. So I'm gonna do, so I do have here is discharged, I'm not sure how badly discharged, but discharged Amazon basic 2000 mAh battery. It's obviously gonna be charging it. But I'm curious to see what would be the charging current with one battery, so MacGyver something like this. So this is my two-sided, this is plastic sheet, is two-sided aluminium foil, so one side gonna be minus and plus, doesn't matter, I just need to actually see the current during the charge. So obviously right now it's not gonna be charging anything, so now we switch to the amp mode here. Just do this. So now I use my crocodile clip thingies and this is gonna be negative clip. Oh yeah, twist this, and this is gonna be positive. Okay, charging. As you see, it's clearly poking in and out. Let's see what's the maximum current here. What are you beeping? I think I don't know how to use it. Oh, it's mean. Okay, minimum. I need minimum, not maximum. Duh. Of course. Doesn't know how to clear it out. Okay, this one. Minimum. Yeah, because I reverse polarity. That's oops. Something went wrong. What's went wrong? It's blinking red. Let's do it again. Let's put proper polarity now and do max. It's not really handy here. Sorry for beeping. That's apparently the It doesn't like the battery for some reason. It stopped. Honestly, I don't know what's wrong with it, but it was poking the battery with like almost 1.2 amps. That's interesting. Okay. Probably this battery is either over discharged or anything, so I'm not sure what's really going on, why it doesn't like it. Let me remove all these contraptions here. Let's just charge it without any kind of interference. Seems to be doing the job. I'm curious if this thing kind of introduced a resistance of a sort, like why I didn't like it, or maybe something else. Like now it seems to be okay. Yeah, keep charging. Okay, well, I mean, that's weird. Maybe there was a resistance higher than usual, and this guy decided, because this is like wimpy. You know, this is okay, but yeah, it's wimpy. Right, guys, I think it's gonna be it. So it's still charging these Amazon Basic batteries, and I think it's a pretty good charger. Just keep in mind, I would prefer actually myself charging 4 batteries at a time, because it's not gonna be pushing too much current in those dinky batteries, especially if those are like suspicious batteries, not like the Ikea Ladas or some ini loops or something like that. So I think this is good charger, and it totally worth, like, I don't know, $8 I pay for it. It's working well, can charge 1, 2, 3 or 4 batteries simultaneously. Charge smaller and bigger batteries, and in general works very well constructed inside, has tons of protections, and I think it's gonna be especially for those amount of money, for like $8.99, it's gonna last long time. It's good to have, for example, in few spots in your house, this charger, some other charger, but this gonna last. So guys, thank you for watching. I hope you like this review of Ikea Stenkol. If you like to see more videos like that, in-depth videos like that, please subscribe, like, comment. I would like to hear from you. So thank you for watching, and see you next time.